Making a video game is not that easy. Just like any other problem, there are more efficient ways to come up with a solution. Today, we are going to make use of some computational thinking aspects, which is an approach to problem solving, mainly decomposition, algorithmic thinking, abstraction, and evaluation. Let's go!
We have decomposition. This is the process of breaking down a problem into simpler, smaller, and manageable problems. Now, in game development, you can't just make one right away. There are different sets of jobs done by different people. We can decompose these jobs into the game design, the art, the development, and the sounds.
Design is one of the most crucial jobs in making a video game. It is the process of designing or creating the rules and contents of the game you want to make. But before you make anything, you must know what you want to make. A video game designer is very much like the director to a film. He or she is the visionary and controls the artistic and technical elements of the video game. The person assigned to this task basically thinks of what the game will be, whether it's a first-person shooter, a platformer, an RPG, or whatever it may be. Video game designers are also responsible for thinking up of the game's characters, plots and storylines, different maps, different scenarios, its difficulties, and most importantly, how to win or lose the game. If the game is a puzzle or level type, video game designers are also responsible for laying out the levels and creating the puzzles to make the game challenging to the player. Because a game that's not challenging is very much like a cell phone that can't text or call.
Art is the more visual side of things. People who are in charge of art are tasked to create the graphics of the game, which is what the players will see, be it the characters, the objects, the background, and etc. There are different types of graphics, mainly pixel and vector graphics, which vary on how they structure images. Pixel graphics makes use of individual pixels. Vector graphics, on the other hand, makes use of mathematical equations to calculate the edges of shapes in relation to one another. This is also where animation is done. Without animation, the game would look pretty static and weird. There are different types of applications used to complete these tasks, but the most notable ones would be Adobe Photoshop, Illustrator, and Blender, which is used for 3D modeling and animation as well.
Since art is on the visual side of the game, sound is obviously on the audio side. People on the sound are in charge of what the player will hear. The sound of the game is composed of dialogue, any verbal speech in the game, the music or score, any non-diegetic music that induces mood in the setting of the game, sound effects, the sound that tells the player what's happening, foley, sounds that the players make, and background, noise from the environment. The way these sounds are obtained is either by recording it or producing it digitally. Sound effects, for example, don't just come out of nowhere. Studios manipulate everyday objects to get the sound they want. The score, on the other hand, is done by a more musically inclined person, usually a composer. Dialogue is recorded by voice actors.
Development is essentially where everything gets put together. Moreover, it's probably the most technical part in game development. Aside from combining all the elements such as the art, the sound, and the design, the developers are usually tasked in handling the physics of the game, how well it would run, controls and ports, and even its user interface. More importantly, the developers make use of something called engines. Game engines are the framework on which these games will run on. It's actually possible for the developer to develop their own engine, but it's more convenient to use the existing engines. For example, the Unity engine, the Unreal engine, and the Game Maker Studio. The engines you will use depends on what kind of game you're making. For example, the Unity engine and the Game Maker Studio is only used when you're making light games. For example, Undertale. But if you're trying to make a heavy game, for example, Injustice or Injustice 2, you use the Unreal engine.
Now that we've decomposed the problem into subtasks, we move on to the next process, which is abstraction. Abstraction is a process of eliminating the too specific details and only getting the important information needed for the job to be done. In other words, the people from each subtask doesn't necessarily have to know how the other subtask will be completed. All they have to focus on is how to get their job done. For example, the game designer does not need to know how the game will be implemented because that is the developer's job. All they have to focus on is how to design the game because that is their job.
The next step is algorithmic thinking. This expresses the step-by-step thought process upon encountering the problem. This is often finite, clear, and precise. You can't really do all of these jobs at the same time. Some of the jobs are dependent on another, which is why there's a specific order in which these are done. Game design obviously needs to be done first, because the art, sound, and development would have no concept to work with. Art and sound could be done at the same time, since they both depend on game design, but not really on each other. Development needs to be last, because it can't really be completed without input from the other three jobs, and since this is where everything is put together. The final CT concept is evaluation. This measures whether your solution served its purpose and is correct. The best solution is often the simplest yet the most effective. In evaluating a game, the design, the art, the sound, and the development must all come together to make one whole game. To recap, the 4 CT concepts include decomposition, which is the breaking down of problems to simpler ones, abstraction, which is extracting the only important information, algorithmic thinking, which is the order of problems needed to be solved, and evaluation, which is knowing whether the solution worked or not. Although these 4 are often associated with computer science and programming, it can also be applied to our everyday lives. Computational thinking is an approach to problem solving, and how one can make things simple. So that's the end of the video. We hope you learned something, and thanks for watching.